Okay, so in part 2, we're going to continue on with the properties of quadratic functions. So in this lesson, we're going to learn about y equals x squared plus c. Okay, so the graph of this parabola is in the form y equals x squared plus c. Okay, and the center will be on the y-axis. The letter C right here represents the y-intercept. Okay? Remember that y-intercepts are where it crosses the y-axis. Okay? So for graphs in this form, the vertex and the y-intercept are going to be exactly the same. So let's go ahead and look at number 1. Okay, so here is the graph of y equals x squared plus 1. So we see that the plus 1, we're rising up 1 on the vertex. Okay, so this point right here is going to be 0, 1. And we also know that the y-intercept is at the point of 0, 1 because they're exactly the same. Okay, so we see that the x squared here is positive, so we know that it's opening up and we're rising up 1. Okay? In number 2, we see that it's a negative x squared, which is why the parabola is facing down. And then the plus 3 represents our y-intercept, so we're going to rise up 3. So the point here, the vertex is at 0, 3, and the y-intercept is at 0, 3 as well. Okay? Moving on. X squared is positive, so it's opening up. And my y-intercept here is negative 2, so I'm going to go down to 2. They are the same points, so 0, negative 2, and 0, negative 2. Okay, let's go over a couple examples of how we can graph these, okay? So we also want to think about how we're going to begin at the vertex, okay? And then we're going to follow the pattern of over 1, up 1, over 1, up 3, over 1, up 5, okay? So it's like the pattern of 1, 3, and 5. Okay, so again, we're going to begin at the vertex. So I see that in number 1, there is no plus c, so we're going to say that it's 0, okay? So x squared, the y-intercept's always going to be at 0. Okay, so I know that I'm going to go over 1, up 1, over 1, up 3. Okay, and I can't go any higher on this side. So on the same on the left, over 1, up 1, and over 1, up 3. Okay, and this will help me graph my parabola. Okay? I can also check to see that it's a positive x squared and it's opening up. All right, in number 2, we're going to start at the vertex. Let me put a little thing right here. Start, you might want to write this down, at the vertex, which is 1. So the y-intercept is at 1. This is negative x squared, so it's going to be opening down. So I'm going to go over 1, down 1, over 1, down 3. Okay, and the same on the other side because this is symmetry. Whatever is on one side is on the other, okay? So opening down, starting at the vertex of 1. And then the last one, we're going to start at negative 4. Okay, it's positive, so it's opening up. So over 1, up 1. Over 1, up 3, and over 1, up 5. Okay, so we're just following the same pattern for x squared. Okay, so again, this is only true if you just have an x squared with the coefficient of 1. Okay, and I'm going to connect here. Okay, so the next part in the check your understanding, this is going to be your practice for today, and so I'm going to skip over it and hand out an answer key later on in class, okay? Okay, now in part 5, we're going to compare the shapes and the patterns of the following graphs, okay? So we've already learned so far about y equals x squared. We know that we go over 1 up 1, over 1 up 3. We make a little arrow, 1, 3, and then over 1 up 5. Okay? So when we have a 2 in part B, a 2 as the coefficient, let's look at the pattern and see what happens. So here we're going over 1 up 2 and over 1 up 6. So we can kind of see that the numbers are doubling here. Instead of having 1, 3, we're starting off with 2, 6. Okay? And then let's check to see what happens when we have 1/2 x squared. So it looks like I'm going over 1 up just a half. Here I'm going over 1 up 1.5. And over 1 up 2.5. Okay? So if I look at the difference between the original x squared, I'm only going up half as much over here. So let's look at the questions. How does the graph of y equals 2x squared compare to the parent graph? Okay, remember the parent graph is the original, y equals x squared. So here it looks like we're increasing by double. And then in the second question, how does the graph of y equals 1/2 x compare to the parent graph? So looking at the shape and the pattern, we're going up just by half. We can also see that in part B, we're doubling the x squared and our graph looks narrower. And when we multiply by a half, a smaller number, the graph actually gets wider. So let's move on to check to see our understanding. So we want to look at the graphs below and put the rules in order from widest to narrowest. Okay? So I can see that the graph in the middle is the widest. Okay? And it's also the one multiplied by a fraction. Okay, so we're making the x squared smaller, so it's getting wider. So the widest would be y equals 1/3 x squared. Okay? Next, when we have the original parent graph, that's just negative, which means it's opening down, it's the standard 135 width. Okay? So that's going to come next. Y equals negative x squared. And then the narrowest is when we multiply by a whole number. So the larger number we multiply by, the narrower our graph gets. In this case, because it's negative, it's opening down. So y equals negative 3x squared. Okay, so I'd like you to take a moment and pause the video and try to fill in the next part. You're going to write a rule for telling whether the graph of a parabola will be narrower or wider. Okay, so something that you could have had was that the closer that the coefficient, the number in front of x, is to 0, the wider it is. Okay, because we see that when we're multiplying it by a really small number, that's what makes it wider. Okay, so I'm going to put the closer the coefficient of x squared is to 0, the wider the graph will be. Okay, you could also say something like the farther away from 0, the narrower the graph will be. Okay? All right, let's move on. Okay, so we want to put these in order from widest to narrowest without graphing them. So I'm going to do the first one. So I know that the widest is the closest to 0. So the first one is going to be y equals 1/2 x squared. Okay. So then the next one closest to 0 is y is equal to negative x squared. Okay, then with the 2 as the coefficient, y equals negative 2x squared. And then finally, y equals 4x squared. Okay, so don't worry about the negative or positive here. This is just telling us which direction the graph is opening, whether it's opening up or down. Okay, so can you pause the video for a moment and try this one on your own? Okay, so what you should have had for here is starting off with 1/2. Okay, so again, closest to 0. Y equals 1/2 x squared. Next would be 3/4. Okay, next closest to 0 is 3x squared. And then finally, negative 5x squared. Okay, so that was it for lesson 10.1 on the properties. Next class, we're going to talk about graphing quadratic functions in the standard form.